Hey guys, this is an examples video of tricky examples of negative exponents. If you've never watched my videos before, pause and try the examples when prompted. Also, there are free guided notes available at divideandconquermath.com where I list all of these problems all like printed out nice for you. So however you want to use those files is fine. So here are the first three I'm going to go through. You can pause the video if you want to read them over. And then here's the other three. So again, you can pause if you want to, but I'm just going to jump right into this. So, okay, starting with the first one. So this is tricky, I think, because it's got the negative exponent out here and a number in here. So I just want to talk about like the consistency of kind of evaluating problems like this. So I am a big fan of just trying to apply the exponent to the whole problem. And by that, I mean like even to this 3. So I'm going to rewrite this as 3 to the negative third. You see what I mean? So I just want to write it like that, and then I'm going to deal with it later. So I just kind of want to write out what is everything that I have to do right now, and then I'll kind of figure it out from there. So let's see, I've got everything set up. Okay, so I'm going to finish all this multiplication first. I'm not even going to worry about this 3 to the negative third at the moment. So this becomes x to the 12th, this becomes y to the negative 15th, and this becomes z to the 6th. And now I can see the only thing I can do next is to really bring this and this to the denominator. So this is going to be x to the 12th, oops, not y, z to the 6th over 3 cubed, and then y to the 15th. Now here's the tricky part after you just did all that multiplication. Remember, this is 3 to the third. That means 3 times 3 times 3. So this will equal x to the 12th, z to the 6th, 27, y to the 15th. It's really common when people do all this multiplication that they try to multiply this too. So just notice if you are prone to that particular issue. Okay, so applying similar logic for b here. So I'm going to just set this up. Now this is a negative number, so I have to be really careful with this. So what I like to do with this is I like to leave the negative number in the parentheses, and then I'm just going to apply this negative exponent. Now remember, you're not multiplying these together. It's you're going to be like in this constant fight with your brain, or some people will be, to like tell yourself you're not multiplying these things together. This is telling you to eventually send this to the denominator. And until we get there, we don't want to do anything with this, okay? So let me just set up the rest of this. So y to the negative third times negative 2, and then z to the fourth, not negative fourth, z to the fourth times negative 2. So let me complete all of my multiplication here. So this is negative 5 to the negative second, x to the negative fourth, y to the 6th, z to the negative 8th. Okay, so now, negative 8th, gosh. Okay, there we go. So now, this, and this all need to be sent to the denominator. So this is going to be y to the 6th over, so notice I'm leaving the negative 5 in the parentheses, but now this becomes positive 2. So I've done what this exponent told me to do, and now I can kind of figure out what this answer needs to be separately. I'll finish writing this out. So now I've got x to the 4th and then z to the 8th. So now I can evaluate this. And remember, this is really, I'll write this out over here. Let's see, I'll use green. Negative 5 squared. This is negative 5 times negative 5. And so that's 25. That's positive. So that's really the importance of this, is figuring out if it's positive or negative. So the final answer here is 25 x to the 4, y to the 6th over 25 x to the 4th, z to the 8th. Okay, so now moving on to C. So the big thing I push for when you see problems like this, so take stock of what's going on. 4x to the negative 5th, y squared over x to the negative 3rd, y to the negative 5th, all of that to the negative 2nd. Okay, so the thing to notice here is that there are things you can simplify in the parentheses before anything else. So what I would recommend is first work on the parentheses before you bring this in, because otherwise if you just start multiplying everything by negative 2, you just create like a lot of extra numbers that you don't need. So we're trying to minimize the amount of numbers that we have, because the more calculation you have, the more likely you are to make a mistake. So let's do this. So this, and this all need to flip their position. So I've got 4y squared, and then y to the 5th, and then x to the 3rd. Normally I put that in alphabetical order, so now that's bothering my OCD. Okay, so let's see. So I've got everything here. So I want to continue to simplify this as far as possible. So notice here I can now add these by using the product rule. So this will be 4y to the 7th. Okay, haven't done anything with the x's yet. And then finally, so I've got x to the 3rd over x to the 5th. So now I just have to do that. I have to take stock of where are there more x's. And this is something I actually explained in the other example video as well. So basically, there's a trick here where you've got to use the quotient rule, but you can kind of like switch up how you're using the quotient rule in thinking about where should the answer actually end up. There are more x's in bottom, so it makes sense that the final answer with the x's should really end up in the bottom. So I'll show you what that really looks like. So this is y to the 7th. So I'm going to just take this x to the 5th, and I'm going to subtract off that 3. And so now this is 4y to the 7th over x squared. Okay, now look at how much simpler this will be to work with this exponent. I have very few numbers left. So now I can flip this whole thing to get rid of this negative exponent. So this becomes x squared over 4y to the 7th, and now this is all squared. And now I can finally just square everything. So I will multiply 2 times 2, so this becomes x to the 4th. And then in the bottom, 4 squared is 16, so this is 16, and then y to the 14th, because 7 times 2. So there's the final answer. Okay, so moving on with these, so this is still the same idea like the last problem. You really want to simplify the inside first before you even worry about this. So if you haven't tried one of these on your own, I'd highly recommend pausing here. So let's see. This, and this are all what have to move. So let's see if I can do all that. So I'm going to leave the x cubed there, bring the x squared up, and then I've got the z to the 4th and the z squared. And then in the bottom, this is 2 y to the 4th and y cubed, and then all of that to the negative 3rd. So notice when I actually like move all of these negative exponents, like when I look at it like this, it looks like I have to use the quotient rule a bunch, but once I get rid of the negative exponents on the inside, as I look through this, I just have to really use the product rule. So I think it gets really confusing with the exponent rules when you have all these extra negative exponents. I prefer to really get rid of them before I use other rules, ideally. Okay, so I can add up the x exponents. So the 3 and the 2 will give me 5. The 4 and the 2, oops, this should be a z. The 4 and the 2 will give me 6. And then in the bottom, this will be 2y to the 7th. Okay, so now notice I have simplified this as much as I can. There's nothing else I can do here. So now I can start thinking about this. Okay, so first let's flip the whole thing. I don't like to do too much too fast. It's really easy to make a mistake with some of these tricky exponent problems. Okay, so now I've got all that cubed, and now I just cube everything. So I'm going to take 2 cubed. So remember, that's 2 times 2 times 2. So this is 8. And then y to the 7 times 3, so this is going to be to the 21st. And then this is going to be 3 cubed, so that's 27. This will be x to the 15th, because that's 5 times 3, and then z to the 6 times 3, that'll be 18. So there's your final answer. Okay, so now for this next one. So in this case, you want to be careful about your simplification. There's only one set of parentheses here, and it's on top. So you can't do the quotient rule right now. You can't move things. You actually have to deal with this set of parentheses before you do anything else. This is very different from the previous two problems, right? Because only one of these has parentheses. So there's nothing else we can really do to this problem until we kind of deal with this fourth exponent. So let's do that. So this is going to be 2 to the 4th, x to the negative 16th, and then y to the 20th. And I didn't do anything to the bottom. So I have to do this because of the order of operations. I cannot start moving stuff around. The order of operations, so you have to deal with the parentheses and the exponent first. Okay, so now, let's see. I'm going to flip-flop this x and this x to get them where they belong. And then 2 to the 4th is 16. So this will be 16 x to the 3rd, y to the 20th, and then this will be x to the 16th, y to the 7th. And now I can see that I've got to use the quotient rule here. So as I look at the x's, there are more x's on bottom than on top. And then when I look at the y's, there's more y's on top than on bottom. So the 16 stays put. The y will stay on top. This will be 20 minus 7. And then in the bottom, this will be 16 minus 3. So ultimately you get 16y to the 13th over x to the 13th. And that's it. Okay, so now for this last one. So this one's pretty crazy too. So we have 3x to the negative 3rd, y squared, z to the negative 3rd, all of that to the negative 2nd. And then 2x to the negative 4th, y to the negative 5th, z to the 3rd, and then all of that to the negative 4th. Okay, so a lot of times when you work on these types of problems, the context matters quite a bit. So the fact that this is negative and that this is negative means I could just at least flip-flop the entirety of these parentheses, which would probably be the best first course of action. So what I mean is this is telling me to move this up here, and this is telling me to move this up here. So let's just do that so that we can maybe make this a little nicer to look at, not necessarily easier, but nicer. Okay, so I brought what was on the bottom to the top. Notice now I changed this to something positive. And then this will be 3x to the negative 3rd, y squared, z to the negative 3rd, all of that to the 2nd. So notice everything inside the parentheses stayed the same, right? The only thing that changed was the outside exponent. So now I can evaluate this, I think, a little more clearly. So I've got all of this to the 4th and then all of this to the 2nd. So let's see. This is going to be 2 to the 4th. This will be x to the 16th, y to the negative 20, and z to the 12th, over, so this will be 3 squared, x to the negative 6, y to the 4th, and then z to the negative 6. Okay, so now I need to move this, this, and this, flip-flop their positions. And we'll also go ahead and evaluate what is 2 to the 4th, it's 16. Then I've got x to the 16th, and I'll bring that x to the 6 up. I've got that z to the 12th, and then I'm bringing that other z to the 6 up. And then in the bottom, this is 9, y to the 4th, and y to the 20th. So now that I've moved all the exponents where they belong, I can see I just used the product rule to finish this. So I'll add the x to the 16th and the x to the 6th. So that's 16x to the 22nd. The 12 and the 6 here. That will be z to the 18th. And then this will be y to the 24th. And so that'll do it for this one. So those were definitely trickier problems. Any questions? Feel free to leave me a comment. Thanks for watching, guys. I'll see you next time.